He's not here yet.
All right, let's get started. So, 1 second. Today we're just gonna go over this stuff on. It's gonna be on page 165, but there's 2 reviews in this book. There's 165 and on page also on 162. Let's do this. This is gonna be. And so I'll send an email out after class today, kind of describing the test. But anyway, all the questions from the test are only going to come from today's video and from yesterday's video. But it's not going to be, because we did a bunch of questions yesterday. The test might only be like 15 or 20 questions. I'm not sure. But you'll have the whole day to do it. But you'll send an email out after this class about that. So let's just go through this chapter 2 stuff. And that's all we really need to do today. So let's look through this and see what's kind of important.
Why?
Can you mute your mic so we don't hear the background noise? I'm not sure whose is unmuted. Okay, let's start with. 1 second. Okay. So I want to do a problem like 4, but I'm going to choose a different one. So this is going to be something like similar to number 4. But let's graph f of x is equal to all these ones in the book are kind of like complex. We don't need it to be that complicated. Let's just make one up. How about something like 2x minus 1 if x is less than 2, or just do minus 2. We could do 3 if minus 2 is less than or equal to x, which is going to be less than 1. And then x if x is bigger than 1. So we want to graph this function. So if you remember with like these piecewise functions, these are the x values where the graph looks like this. So when x is less than minus 2, the graph looks like 2x minus 1. When the graph is in between minus 2 and 1, the graph looks like 3. And when x values are bigger than 1, the graph just looks like x. So what we said for this, the technique to doing this is we need to make an xy table for each of these 3 pieces over here. So let's do that. Let's write 3 xy tables. So this first one will be for the first equation, 2x minus 1. Our second one will be for the second equation. And the last one will be for the last equation. So we have 3 xy tables. And we want to have 2 points in each table for the x values to plug in. And for sure, one of the points we want to plug in, regardless of this sign, whether it's a strictly inequality sign or if it's has the or equal to part on the bottom, we want to plug in the numbers we see to the right of it. So on this one, we only, sorry, what's going on here? So for this first equation, you see, we only see, if we look to the right, we only see the number 2. Let's make that 2 a little bit better. So we only see the number 2 over there. So for sure, we're going to, or sorry, minus 2. We're going to want to plug minus 2 into here. If you look at the middle one, we see 2 numbers. We see minus 2 and 1. So we're going to put minus 2 and 1. And for the last one, you see we only see the number 1. So we're going to put the number 1. But each table needs to have 2 x values. So it just so happens the middle table is done. We don't need to add any other x values. But we need to add an x value to the table on the left and the table on the right. And an x value we want to add, it has to be inside of this section. So an x value such that it's less than minus 2. So let's just plug in minus 3. And over here, we need an x value that's bigger than 1. Let's just plug in 2. Okay, now let's calculate, what are these values? So if we plug in minus 2, so we're looking on the left side over here. If we plug in minus 2, we're going to get 2 times minus 2, which is minus 4. And we subtract 1, which is minus 5. So let's plug in minus 5 here. But remember, minus 2, we're not allowed to plug in minus 2 to this top equation because minus 2 is not less than minus 2. We have that strict inequality sign there. We don't have the or equal to part. So just to keep track of that, we're going to put an open circle next to it. Minus 3, if we plug that in, we get 2 times minus 3, which is minus 6. And we minus 1, that's minus 7. And we are allowed to plug in minus 3 because minus 3 is less than minus 2. So we're going to put a closed dot next to that one. Okay, so that table's done. Let's move on to the next table. Minus 2. So in this middle equation, no matter what number we plug in, we always get the number 3. So 3 here, 3 here. And minus 2, we're allowed to be minus 2 because you see how we have the or equal to sign. So we could put a closed circle here. But we're not allowed to plug in 1, you see, because we have this less than sign. And 1 is not less than 1. So to keep track of that, we're going to put an open circle on this one. Now, the last one. So this is just y is equal to x. Whatever the x value is, that's what the function is. So this is going to be 1 here, and this is going to be 2 here. And, oh, sorry, this needs to be an or equal. This needs to be greater than or equal to. Okay, so now we're allowed to see, we're plugging in an x value of 1. We're allowed to plug 1 in here because 1 is bigger than or equal to 1. So we'll put a closed dot because we're allowed to plug that one in. And same with 2. 2 is bigger than or equal to 1. So we're going to put a closed dot on this one. All right, so now after doing this step, all the XY tables are done. So now what we can do is like draw the graph. So let's do that. So here's, let's put a dot on minus 2 and a dot on 1. What are the values? And we also did minus 3. And then we did 2. Okay, so what do we have here? We have, looking at just starting at the left table, when x was minus 2. So look over here, we had minus 2, minus 5. So here's minus 5. And then that was an open circle, minus 2, minus 5. And the other one from there was minus 3, minus 7. Minus 3, minus 7, and that was a closed dot. And we always connect the, so we're going to start here and go in this direction. So we always connect the dots from the same XY table. All right, now let's move on to the next section. At minus 2, that was 3. Let's put a 3 up here. And that was a closed dot for this guy. And then at 1, 3, we had an open dot. So we connect those guys together. And then on the far right table, we had 1, 1. So here's 1. And that was a closed dot. And then we had 2, 2 with the closed dot. And those came from the same table, so we're going to connect those together. And so from these, sequence of steps, we get our graph, which looks like this. Okay. All right. Let's do some maybe I guess we could do 6, 7, 8, and 9. All right. So for the 6, 7, 8, and 9, well, it uses these functions. Let's write these down first. So f of x is equal to x squared. Oh, wait, that's fine. X squared minus 4x plus 3. And g of x is equal to the square root of 3 minus x. So let's see, make a little note of this. Use these for numbers 6 through, so 6, 7, 8, 9. All right, so for number 6, what we want to find is f plus g of minus 6. All right, so if you remember what this actually means is all we're doing is just add the two functions together. So this is going to be f of minus 6 plus g of minus 6. And so we need to plug minus 6 into f, so that's going to be minus 6 squared minus 4 times minus 6 plus 3. So there's f. And now plus g of minus 6, which is just going to be square root 3 minus minus 6. So here we're going to get 36, let's see, 6, 12, 18, 24, plus 24, plus 3, and then that's plus square root of 9. So what do we have there? We have 63 plus 3, which is equal to 66. All right, let's do number 7. So number 7 asks us to find f minus g of minus 1. And what this means is we just do f of minus 1 minus g of minus 1. And what that equals is, so let's plug minus 1 into f, which is going to be minus 1 squared minus 4 times minus 1 plus 3. So here's f. And then minus g, which is square root of 3 minus minus 1. So this is going to equal 1 plus 4 plus 3 minus square root of 4. Okay, so we have 1 plus 4 is 5, plus 3 is 8, square root of 4 is 2, so we get the answer of 6. Okay, number 8 is asking us to find f times g of 2. F times g of 2. So this is going to be f of 2 times g of 2. So what is f of 2? F of 2 is going to be 2 squared minus 4 times 2. Minus 4 times 2 plus 3. Okay. And then g of 2 is going to be square root of 3 minus 2. So what we have here, 2 squared, that's going to be 4 minus 8 plus 3. And then that's going to be multiplied by the square root of 1. So what we have here is 4 minus 8 is minus 4. Minus 4 plus 3 is minus 1. And then square root of 1 is just 1. So our answer here is just minus 1. Okay, number 9, f divided by g of 1. All right, so let's see. We have, this is just going to be f of 1 divided by g of 1. F of 1 is going to equal 1 squared minus 4 times 1 plus 3. Now divided by g of 1, which is the square root of 3 minus 1. So this equals 1 minus 4 plus 3 divided by square root of 2. And that is going to equal, so 1 minus 4 is minus 3. Minus 3 plus 3 is 0. So let's just write that. So we have 0 over square root of 2, which is just equal to 0. Okay. Let's do some from like, oh, okay. So let's do like some of the following. So we have like 10 through 19, I believe, are, yeah, so 10 through 19 are kind of like all similar. So let's do one of those. So for these, we want f of x. We're going to change this. So f of x now is x squared. And g of x is equal to square root of x minus 3. So let's just choose a couple from 10 through 19. So we're going to use these for the following questions. All right, so let's do let's start with number 12. So we want to find the domain. Find the domain of f plus g. All right, so first let's figure out what is f plus g. So f plus g of x, that just means f of x plus g of x. F of x is x squared. G of x is x minus square root of x minus 3. So we want to find the domain, and like we always say, with domain, we only worry about two things: fractions and square roots. So we see no fractions here, so there's nothing to worry about with that, but we do see square roots. And whenever we see a square root, the inside of the square root needs to be bigger than or equal to 0. So our inside of our square root is x minus 3. So what we need is x minus 3 needs to be bigger than or equal to 0, which just means that x needs to be bigger than or equal to 3. So on the number line, we have 3, closed out on 3 because we have the or equal to sign, and it's saying x has to be bigger than or equal to 3. So bigger than 3 means we shade to the right. So this tells us that our domain is going to be 3 to infinity. All right, let's do 15. So we want to find the domain. Find the domain of f divided by g. So what this means is, so we have f over g of x. That's just the same thing as f of x over g of x. And so f of x is x squared. And g of x is square root of x minus 3. All right, so domain, same thing. Are there fractions? And are there square roots? In this situation, we have yes to both. So let's start with the fractions. We can't have the bottom of our fraction being 0. Here, our bottom of our fraction is square root of x minus 3, so that can't be 0. So the square root of x minus 3, this is not allowed to be 0. But if we just square both sides, this tells us that x minus 3 can't be 0. Since we can square the left-hand side, square the right-hand side, 0 squared is 0, and if we square the square root of x minus 3, that just becomes x minus 3. So we can't have that being 0, and then that means if we add the 3 over, x is not allowed to be 3. Okay, so there's one thing. X is not allowed to be 3. Now what about for the square root part? Well, the square root says anytime, anything on the inside of the square root needs to be bigger than or equal to 0. The inside of our square root is x minus 3, so we need x minus 3 to be bigger than or equal to 0. So if we add the 3 over, x has to be bigger than or equal to 3. So both of these things need to happen. But notice this is saying x is bigger than or equal to 3, and this is saying x is not allowed to be 3. So we need to combine both of those things. So let's go to a number line. Here's 3. This is saying x is not allowed to be 3. So we're going to put a circle on 3. If it was just for this, we would be allowed to be 3 because 3 is bigger than or equal to 3. But we need to take both of these things into consideration. And this one is saying x is not allowed to be 3. So really all we can take from this is x is going to be bigger than 3. So we're going to shade to the right. And so this is going to be our domain. Our domain is going to be 3 to infinity, but with a parenthesis on 3. All right. That's good for now. Let's move on to some other questions. Okay, let's do a difference quotient problem. So let's just write this down. Remember that the difference quotient This is going to be equal to f of x plus h minus f of x all divided by h. So that's the difference quotient. And so for this next problem, let's do it with 21. So we want to find the difference quotient. Find the difference quotient of f of x is equal to x squared or 2x squared minus x plus 3. Okay, so in order to find the difference quotient, we need basically only to find one thing. We need to find f of x plus h, and then we just plug it into the difference quotient. So we know what f of x is, and this h is all you do is you just divide by h. There's nothing to find there. So the only thing we really need to calculate is f of x plus h, and then we can find the difference quotient. So here's f of x. We're given to this in the problem. So now let's find f of x plus h. And so remember again, this x, whatever goes, we plug inside these parentheses, that goes here, and it goes here. So now if we're going to plug in, we're going to find f of x plus h. All we do is we just plug in x plus h in wherever we see that green box. So we're going to have 2x plus h squared minus x plus h plus 3. Now let's simplify this. This is going to equal 2. And if we square out x plus h squared, we're going to have x squared plus 2xh plus h squared. Now let's distribute the minus sign. Minus x minus h. We have our plus 3. So this is going to be, we'll have 2x squared, 4xh, 2h squared, minus x minus h plus 3. What do we got now? 2x squared. Not too much simplifying we can do actually with this. Oh, there's no simplifying we can do. Don't need to write another line. Okay, so now we can, we have, this is equals f of x plus h. So we have our f of x plus h. We have our f of x, and so now we can fill out the difference quotient. So our difference quotient is going to equal f of x plus h. Let's just rewrite that piece. We have 2x squared, 4xh, 2h squared, minus x minus h plus 3. So here's f of x plus h minus f of x. So let's just plug in f of x right here. 2x squared minus x plus 3. And then all of that is being divided by h. So now let's just, see if we can cross out anything or simplify a little bit. So rewriting the top, let's distribute that minus sign. So we have 2x squared, just rewriting this beginning piece, 4xh, 2h squared minus x minus h plus 3 minus 2x squared. Now we have a plus x and a minus 3 all over h. So some things should cancel out on the top. So you notice here's a minus 2x squared, a plus 2x squared, a minus x, a plus 3, a minus 3. That's it. And so what we're left with is we have a 4xh, a plus 2h squared, and then the minus h. So these are the only things we have left, and it's all divided by h. And the last thing we could do is we could factor out an h on the top. So let's take out an h. We have 4x, 2h minus 1, and then that's divided by h. So now those h's cancel on the top and the bottom, so we have 4x plus 2h minus 1. All right. So this will be our final answer. This is the difference quotient. Okay, let's do. I want to do something similar to 22 to 25. It's going to be similar. So let's for the following, let's just let f of x is going to be equal to 1 over x plus 1. And we can let g of x be equal to, what do we want to let this be equal to? Is this gonna be good? This should work. Oh, sorry, let me think for a second. Yeah, let's do it like this. So let's let f of x be 1 over x plus 1, and then g of x is going to be x plus 1 over x. So now let's find the domain of, let's do f composed with g of x. So remember, this is not multiplication, this is the composition. So first, let's figure out what does that equal. So f composed with g of x, this just means we're plugging g inside of f. So we have f, and we're plugging g of x on the inside of it. So again, whatever goes inside of this, parentheses, this x, all we do is we put it right here. So now what we're doing is we're plugging g of x inside. So this is just going to equal 1, and we're replacing that green box with g of x. So g of x plus 1. And what that equals is, well, g of x is x plus 1 over x. So this is going to be 1 divided by x plus 1 over x plus 1. And so now we're going to do no simplifying. We want to find the domain. When we find the domain of these composition functions, once we plug in our function, that's when we take the domain. So we're not going to do any simplifying. We're going to find the domain of this. So now for the domain, remember that, so let's again write those two things out, square roots, fractions. So we don't see any square roots, but we do see fractions. So we see fractions in multiple places. This whole thing's a fraction, and here's the bottom of that fraction. So we can't have that being 0. So x plus 1 over x plus 1, this is not allowed to be 0. And another place we see fractions, well, here's a fraction, and the bottom of that fraction is x. So another thing we have to have is x is not allowed to be 0. So those are the two fractions in this problem. This one, there's really no work to show, we're done, just x can't be 0. Here we have to kind of do some work on this one. So let's subtract that 1 over to the other side. So we get x plus 1 over x. This can't equal minus 1. Then what we can do is we can multiply the x over. So we get x plus 1. This cannot equal minus x. So then what we can do is we can add the x back to the other side. So we get 2x plus 1. This is not allowed to be 0. And then we can subtract the 1 over. 2x cannot be minus 1. And then we can divide by the 2. X is not allowed to be minus 1/2. So we get both of these things. X is not allowed to be 0, and x is not allowed to be minus 1/2. So we go into our number line. Here's minus 1/2. Not allowed to be that. Here's 0. We're not allowed to be that. But those are the only problems that we came up with. So everything in the middle is okay. Over here is all right. And then over here is okay. So our domain is going to be minus infinity. Minus infinity up to minus 1/2. Minus 1/2 to 0. And then 0 to infinity. All right. And that's going to be our domain for this problem. So now let's do, so we just did f composed with g of x. Let's do g composed with f of x. So let's find the domain. Of g composed of f of x. All right, so now what does this equal? So g composed with f of x, this is going to be equal to g, and we're plugging f of x on the inside. So let's go back up to what are the definitions? So remember, whatever g is, this green box, that's what we're plugging in. We put that here, and we put that here. So now what we're putting on the inside is an f of x. So we're going to replace that green box with an f of x. So we'll have f of x plus 1 on the top. And then there was an f of x on the bottom. And so what does f of x equal? We see up here, it's 1 over x plus 1. So what this is going to equal is 1 over x plus 1 plus 1 all over 1 over x plus 1. All right, so this is what we want to find the domain of. Again, the things that we're looking for a domain are square roots and fractions. No square roots here, so nothing to worry about, but we do have fractions. So this fraction's in multiple places. This entire thing's a fraction, and here's the bottom of that fraction, 1 over x plus 1. So 1 over x plus 1, this is not allowed to be 0. Okay, we see there's a fraction down here, and the bottom of that fraction is x plus 1. So x plus 1 is not allowed to be 0. And again, that same thing's on the top. There's a fraction on the top. The bottom of that fraction is x plus 1. So this is just redundant, but we'll write it again. X plus 1 can't be 0. But these two things are the same thing, so it doesn't really matter. But just to kind of be complete, we'll write that out. All right, and those are the only fractions that we see. So now let's solve each of these things to see what happens. On this left-hand side right here, let me move this over so we have a little bit more room. So we want to solve this one now. Note, let's rewrite that underneath of it again. So 1 over x plus 1 doesn't equal 0. If we multiply the left-hand side by x plus 1 and the right-hand side by x plus 1, well, on the left-hand side, those x plus 1s cancel, and we just have a 1. On the right-hand side, we get 0 times x plus 1, which is just 0. But 1 is never equal to 0 anyway. There's really, we don't really get any information out of this. So what we can sort of just say like there's no solution here. So what this basically means is that 1 over x plus 1 is never equal to 0. So there's nothing to worry about, actually. So when we look at this whole thing as a fraction, and here's the bottom of this fraction, we find that this bottom piece is never equal to 0. There's no x value we can plug in to get 1 over x plus 1 to be equal to 0. So as far as the domain goes, there's not going to give us an issue there. But this one's quite easy. The middle one's easy to solve. We just subtract the 1 over. We see x can't equal to minus 1. So that's something that we have to take into consideration. Same with over here. We get x can't equal minus 1. So that's really the only problem is x being minus 1. So that's what we're going to get rid of. So we go to our number line. Here's minus 1, put a circle on it. But everything else is okay. So everything to the right's okay. And then everything to the left's okay. So our domain's going to be minus infinity to minus 1. And then minus 1 to infinity. All right. Let's do like some even, odd, and neither stuff. So this is going to be kind of similar. I want to do some more though. This will be similar to 30. So for these following 3 questions, we'll just do like, are they, so, how do we want to write this? So are the following functions even, odd, or neither? And let's do the first one. We could do the one in the book, 2x over x plus 1. So remember, 2x over x squared plus 1. So this is the one from the book. We'll do 2 others too, just to give examples for all 3, an even function, an odd function, and a neither. So remember when we're doing, let's just call this f of x. So when we're doing even, odd, and neither, we need to, well, we can write the definitions off, maybe squeeze that over here. So even, what this means is that f of x is equal to f of negative x. And then odd means that f of x is equal to negative f of negative x. And then neither just means that neither of those 2 things happen. So what we need to find is f of negative x and negative f of negative x to see if we have any types of equality. So let's first start with f of negative x. So all we have to do is just replace all the x's with negative x's. So this is going to be 2 times negative x all over negative x squared plus 1. And this is going to equal minus 2x. And the negative x squared, the negative goes away down there. So we just have x squared plus 1. And this negative, this is this negative. All we do is just writing it in the front. Okay, and now we need to find negative f of negative x. So negative f of negative x, well, we just found negative x in the previous problem. So all we need to do is put a minus sign in front. So here's this minus sign is this minus sign. And so now in the parentheses, we're going to plug in f of negative x, which we just found to be right here. So minus 2x over x squared plus 1. And that is just equal to 2x over x squared plus 1, since those minus signs cancel. And so actually what we see is, well, above, here's f of x. Here's f of negative x. And then here's negative f of negative x. And so let's see, what do we have? Well, we see that f of x is not the same thing as f of negative x. So it's not even. But we do see that f of x is actually equal to, so down here we have negative f of negative x. That's just the same. So f of x is the same thing as negative f of negative x. So that means our function is odd. Okay, so for this problem, here's our answer. Our function is odd because we have this. All right, how about, we could do it with the function g of x is equal to x squared plus x to the fourth. So for this one, we need to find g of negative x. Okay, so let's plug in negative x. We'll have negative x squared plus negative x to the fourth. So since we have even powers, those negative signs are going to go away. So we have x squared plus x to the fourth. Let's just stop right there for a second. And now let's move on to negative g of negative x. So all we're doing is we're plugging a negative in front of g of negative x, which we just found to be x squared plus x to the fourth. And so this is going to equal minus x squared minus x to the fourth. So from this, we see that g of x is actually equal to g of minus x. And then we also see that g of x is not the same thing as minus g of minus x. So we have our function as even. So this tells us it's not odd. So all we have is that g of x is even. In our last example, how about we do it with h of x is going to equal x to the 3 plus x to the squared plus x. So we need to find h of negative x. So this is going to be minus x cubed minus x squared plus minus x. So if we take a negative to an odd power, it stays. So we're going to have minus x to the 3. Here the minus sign goes away, so x squared, and there the minus sign stays. So there's h of minus x. And so now if we're going to find minus h of minus x, this is going to be minus x cubed plus x squared minus x. And what we get is x cubed minus x squared plus x. And if we look above, we see there is no, like, h of x is not the same thing as h of minus x. And also h of x is not the same thing as minus h of minus x. So it's not even. It's not odd. So we have this function is neither. Okay. There's one question on here that will be on the test, but I don't see it in this. We went over it. I don't know why this actually isn't in here. It's kind of like sort of like 31, 32, and 33, or 31 and 32. We'll do two more together. So what we're going to want to do is use transformations to graph. Let's do f of x is equal to 2, x plus 3 minus 1. And then we want to graph each transformation. Oh, this is squared. Okay, so what we need to start with is with these functions, or when we graph with, like this type of problem, we need to first find the parent function. So our parent function, we remember, is we look at our equation and we get rid of every number that's not an exponent. So we're going to get rid of the 2, get rid of the 3, and then we're going to get rid of the minus 1. And what we're left with is just an x squared. So x squared is our parent function. And then our first transformation, we start with things closest to x and move away. So that plus 3 is the first thing. So our first transformation is x plus 3 squared. The second will be that 2 in the front. We have 2x plus 3 squared. And the last thing is that minus 1. So we need to graph each transformation. So we'll have 4 graphs total. So we start with the graph of x squared. That's just a parabola. Here's x squared. And so say if we know the point 0, 0 is on x squared. If you plug in 0, you get 0. If we plug in the number 1, we get 1. And if we plug in the number minus 1, we get 1. So those points are on this graph. So now let's move on to our first transformation. So remember when we add 3 directly to the x, whenever we add and subtract directly from the x, what we do is we take that number and we subtract it from the previous x values. So this number 3, we're going to subtract all the previous x values 3. So another way we can think about it is sort of backwards. Whenever we're adding a number to the x, we move into the negative direction. And then if we were going to do something like x minus 3, if we're subtracting from the x, we move into the positive direction. But since we're adding directly to the x, we're adding this 3, we're going to shift everything to the left 3 units. So this point right here gets shifted to the left 3 units. Shifting to the left means we're subtracting all the x values by 3. So that x value in that point is 0. So now it's going to be minus 3. So we have minus 3, 0. So notice the y value doesn't change. We're only moving to the left and to the right. So this point 1, 1, that gets moved over to the left. So now it's going to be at minus 2, 1. And then the point minus 1, 1, it will get moved over to the left 3 units. And now it's going to be at minus 4, 1. Then we connect the dots with that same shape. All right, and so there's the next graph. And now number 2, our second transformation, the 2 in the front. So now what this 2 does is we take all of our y values and multiply it by 2. So all the previous y values, this point right here has a y value of 0, so nothing happens. That stays at minus 3, 0, because 0 times 2 is 0. This has a y value of 1, so if we do 1 times 2, we get 2. So now it's a y value of 2, of minus 2, 2. This has a y value of 1, multiply that by 2, it becomes 2. Minus 4, 2. Then we connect all those guys. And now the last one. So this minus 1 on the outside means we take all of our y values and subtract 1. So here we have a y value of 0. We subtract 1. Now it's going to be a y value of minus 1. The other point up here, we had a y value of 2. Subtract 1, we get a y value of 1. Here we have a y value of 2. We subtract 1, we get a y value of 1. Okay, and so this is the graph that we wanted, but in order to get to there, we had to do these 3 previous graphs. Okay, let's delete these guys. All right, let's do one more together. So let's use transformations. To graph f of x is equal to minus square root x minus 1 plus 2. So start with the parent function. So our parent function, get rid of all the numbers that aren't exponents, and all we're going to be left with is square root of x. And then our first transformation, the thing that happens closest to the x is that minus 1, so square root of x minus 1. The second thing is going to be that minus sign on the outside, so minus square root of x minus 1. And then the third thing is going to be minus square root x minus 1 plus 2. So let's start with the parent function. So this is sort of, again, like these general shapes are just ones you sort of need to have memorized. So what the square root of x looks like, it starts at the origin, and then it moves up like this. So we have this point 0, 0. Another point we could put on here is we have the point 9, 3. If we take the square root of 9, we get the number 3. So there's 2 points on this graph. Now let's move over to the first transformation. So now we have x minus 1. So because we have a minus 1 to the x, we need to move everything to the right 1 unit. So this point is going to move over to 1, 0. And then the other point we have on there is going to move over to 10, 3. Again, all we're doing is adding 1 to all the x values. So this has an x value of 0, moves over to 1. This has an x value of 9. That moves over to 10. Now we do the minus square root of x minus 1. So this minus in the front means we multiply all the y values by a minus sign. Well, that's a y value of 0, so nothing changes there. Positive 1, not minus 1. And then this has a y value of 3, so now that becomes minus 3. So 10 minus 3. We connect those with that same shape. So basically the graph just turns upside down. And then our last thing is that plus 2. So the plus 2 on the outside of everything, that means we add 2 to all the y values. So our previous point right here of 1, 0, that's going to move up to here to 1, 2. And here's 10 minus 3, that's going to move up to 10 minus 1. Let me connect those guys. And then this will be our final answer. Okay. I think it's a good place to stop. So all these questions, these are going to be, the only possible questions we can get from chapter 2. And then the video from yesterday, those are going to be all the questions that we can have from chapter 1. Again, so I'll send out an email just kind of like telling in more in detail of what we got to do tomorrow. But basically, I'll just post the test tomorrow morning, and you'll have to like tomorrow till midnight to finish it. Okay, cool. So thank you. Yeah, just feel free to send me an email if you have any questions on any of this stuff. Yeah, otherwise, good luck studying, and good luck on the test tomorrow. Cool. Thanks.